Welcome to In the Loop, a New England Temperature Solutions podcast. In today's episode, Dominick DeLuca, president at NETS, will be discussing infrared applications with Greg Secord, Fluke Process Solutions Northeast Regional Sales Manager. Greg has been the regional manager for Fluke, Raytec, and Ircon since 2009 and has extensive technical and management experience in the industry. Without further ado, here's Dom and Greg helping you get in the loop.
Hello. Welcome to our podcast today, In the Loop. Today we are here with Greg Secord. Greg is from Fluke Process Instruments. Would you tell us a little about yourself, Greg?
Hey, Dom. Thanks for having me. I'm the regional manager for the Northeast for Fluke Process Instruments. We sell all the fixed, mostly infrared temperature solutions for monitoring production processes within Fluke.
Okay. And where do you live? I'm
in New York State.
Okay. Did you feel weird coming into Patriot territory, although we feel weird being in Patriot territory now?
Well, as you know, I'm kind of a Bills guy,
Yes.
So it's usually hostile territory. But
we'll be
I'm
nice
feeling
to
better
you.
about it every year.
We'll be nice to you. Be nice to you. We put this TV in our new podcast, and the box is right there, and it's got, what team is that? The Chargers?
Chargers.
I'm staring at a Charger. We should really have caught that before we bought this TV. But so tell me a little about your family.
All right, they're getting up there now. I've got a son in college.
Wow.
Got my daughter's in high school. Been with my wife for 24 years now.
Wow.
And
You still have
cruising
all
right
your hair?
along. Still with Fluke. Still have my hair. That's a good sign.
That's good.
It's getting
That's
a little
good.
gray.
And how long did you say you were with Fluke?
With Fluke, about 26 years. Fluke Process Instruments, about the last 8.
Okay. And your the product line you cover for Fluke Process Instruments is?
It's thermal imaging, line scanners, pyrometers, also known as fixed
Spot
infrared
sensor.
temperature sensors or spot sensors. Yeah.
Okay. And then you have another product you guys are doing now too?
Now we have something called a sonic imager, which
Okay.
helps to check for high-frequency noises, which usually amount to leaks. That's the biggest application for it. That's been getting a lot of interest, and we have, of course, a portable version and a fixed version.
Okay. And your territory?
My territory is the Northeast. It's a pretty broad territory. It goes from Virginia over to Ohio all the way up to New England, where you guys are.
And apologize to our audience. You forgot the bagels today. You're supposed to bring bagels from New York.
Yep.
You forgot them.
I have a reason to go back.
Right.
Reason to come back.
Reason to come back.
That's right.
So today we want to talk about infrared imagers, and it's a little different than a spot sensor, and
Right.
we have one. This is one of the ones we're going to talk about.
Absolutely.
So what do you do with an imager?
All right. Well, this is our latest. You can see thermal imager. It looks and it acts a lot like a camera, although the image that you're getting is really just us assigning temperatures to all the different pixels of temperature data that you get. So instead of like an infrared sensor, a spot sensor, getting one temperature out of your instrument, you're going to get actually a whole matrix of them. And we already said it's a 640 by 480 matrix. So that's 300,000 different temperatures streaming out of this at once. And so the reason you might use something like this is so you can monitor a whole area, look for differences in temperature, look for hot spots that you don't know where they're going to occur, things like that.
Mm-hmm. And the industries that this is sold in vary?
All over the place. You know, we haven't been so much with a lot of our products in the food industry, but we found ourselves going into food industry a lot. Plastics, anything that's, having a moving stream of product or devices down a conveyor, it's pretty commonly used. Or anywhere where you're monitoring for hotspots, they could be a danger, which means almost anywhere.
Or cold spots. I know there was a food application where they were stuffing something, and if it wasn't stuffed with the appropriate material, other food, it showed up as a different temperature. It was actually colder because they was putting something hot in the middle of this thing. So its real claim to fame is differential temperature across a 2D image, right?
Yeah.
So as we see here, we have the picture right here of that's a heater that we had in the other room that we took a picture of, and you can see the coils and the temperature behind it and all that. So
Right.
So there's 2 imagers that we sell. Actually, there's 3 if we talk about the scanner. So why don't we talk a little bit about the scanner?
Okay.
The difference between a scanner, because I get asked that. What's the difference between a scanner and an infrared imager?
Well, some of our partners will describe for people to make it as simple as possible that we have items that can give you a temperature in the format of a point, which is most of the pyrometers, a line, or an area. And so what we're holding here gives you an area. A line scanner would use a pyrometer bouncing off a rotating mirror that lets you use that same point sensor to get a number of temperatures across a line. So you can take that line, it goes out, fans out at a 90-degree angle, put it across usually like a conveyor belt or some process that's moving, and that will build up a full 2D image of temperatures.
And it can look like the picture you're seeing can look like your process, and you can show the differential temperature across it.
Yeah.
And the beauty of that is it can account for moisture or lack of moisture in area, different spots, thickness, thinness, and then holes in a web process show up like 4th of July a lot of times. So
yeah.
Okay, so that's the scanner.
And with a scanner, the only way you can see a full 2D image is if you have motion of the product. So that line is always in the same place. The product moves by, and then you build up a number of different lines that eventually looks like a 2D image.
Got it.
You know, with this little guy with a thermal image, you're always looking at a 2D image. Even if the process isn't moving, you can monitor that whole image like the one we have here for any changes or anything that you care about.
Okay. So we have this new one, the 130, and then the TV30. I'm sorry, the TV30, and then we have the TV40. We'll talk about the TV40 in a minute. But so this camera, what does it do for us?
This is we say TV30, and that's the whole series. The real products are going to be either the TV33 or the TV36, right? We either have the standard resolution or we have the maximum or the increased resolution of the TV36. Previously, we had a TV43 and a TV46, so we call that the TV40 series. So this one's a little, we went kind of backwards in model numbers. That's not typical, right? You hardly ever go smaller than you go bigger. But the product actually got a lot smaller. So this is about half the size of the previous product. The price tag actually got a little bit smaller, which is kind of attractive to, especially for people who might need multiple cameras to solve the application. And then you still have a feature set that's really on par with what we had before. But as we've talked about, one of the most attractive things about it is now we have something called a standalone camera. So this imager could be connected without connecting to a computer, without going through any software that's off of the camera itself. It can connect directly to a PLC or some other device where you want to get that temperature to.
Yeah, and what I like about this compared to the other ones, a perfect example is this picture here that you see, would have created it if I wasn't 64 years old, would have created it a lot sooner, but I forgot the password. So, but we literally went in and got this picture set up. You see, I drew an area around that heater, and we're displaying the values here. But we did this in 5 minutes. Right?
Yeah,
Turn the heater on. It took 5 minutes. That is just not normal for historically what an imager would do. Yeah. And it runs off of it's a Google Chrome, Google.
Yeah,
just a web
Internet
server.
Explorer, any of those browsers. Okay. I like that because if I come and show someone the camera, I connect it up to my computer. It's not really important that it's my computer. We can switch it over to somebody else's laptop. As long as you have a browser and you know the IP address, which might show up here, you can plug right into it, and everything's being driven by the camera itself on the standalone version. It's really all firmware here, no special software needed on top of or on the computer.
Okay. So the claim of an imager is to tell differential temperature from point A to point B potentially, or absolute, but a lot of times it's absolute based on an area. So what are some of the features in here that allow you to do that?
Well, I think the geometry involved is kind of one of the key things. So we talked about how a line scanner works. You could really use this just like a line scanner if you want to. So the different geometries that you can set up on that screen would include, say, a line, and you can graph that data, or you can just take all those pixels of data across it. You can look, does my temperature equal the same thing on the left as it does on the right? You can also look inside that area and start to get things like, what's my maximum temperature inside of that area? What's the average? What's the lowest temperature? You can start to do a lot of things, and you can start to apply math to that to say, what's the difference between, say, box number 1 and box number 2 here. So depending on what you're trying to achieve and monitor for, you can do a lot with this.
We'll get to the math in a minute, but so there's a point that you could trend, right? You could look at the point. Then there's the line, which we can draw, which would give you the max, the min, the average. And then there's a square, which could give you the max, which is your hottest spot. And then there's this, which we did here, which I was able to trace that heater,
Right.
which is pretty cool.
Yeah, and you don't even need areas of interest. You could say, tell me what's the average temperature on the whole screen or the hottest temperature on the whole screen. But the reason you might care about that or want to draw an area of interest like that is that you may have really hot temperatures in the background that are not a problem because they are in the background, and you want to sort of ignore them for the purpose of alarming or controlling on the hot spot that you've outlined there.
Right. Plus, we can change the range here, right? So that matter of fact, this is a little too low. We know that the max temperature in that is 769 C,
Right.
and the min temperature is 135, which is probably the purple. So, is that right? Yeah, that's right. Yeah. So we can adjust to make the picture look more brilliant, get a little more resolution for temperature.
And you can have completely different limits for each different area on the screen. So on the first one, you could have, the surface could be known to be much different on box 1 than it is on box 2. So you can apply a different emissivity. You can have limits that say, I want to make sure that box 1 doesn't get over 200 degrees. Well, box 3 is okay if it's up to 600 degrees. And you can have alarms set for all different temperatures, different limits appropriate for those.
Okay. And then I just basically took a screenshot of this, stored it. But this data, these data points are available offline.
Yeah.
You can get them out.
Multiple ways you can get it out. We have, I guess I'll uncover it here. We have a 12-pin connector on the back. So 3 of these pins could be set up to be a direct line out. It essentially works like a relay. So you just have a digital on-off switch. So if you assign, let's say, number 3 here, if you said anything here gets above 600 degrees, I want this alarm to trip. And you'll see in your indication here, you see the red box around the screen in the shot that you took. That indicates that you are exceeding one of the limits that you set up. When that happens, you could essentially flip the switch on one of those outputs. You have a direct line going to a PLC or a system that's going to alarm for you, and that would trip it right there. If you have more than 3 outputs, or if you want to do something more specific, like you want to give a proportional signal out that equals one of your temperatures, you can get separate modules. So the camera talks through an Ethernet cable out to a module. The module will then give you either a digital or an analog signal out that can then go to your PLC. So if you want to have 4 to 20 milliamps that's equal to the max temperature in test area 2, you can assign that. And then you can have all kinds of things streaming out that way.
Okay. Or you could directly connect it to your PLC. It could read the data in through OPC.
Yeah.
And do control if it needed to.
And that's a much nicer solution, really. So directly across that Ethernet cable, you have several different formats where you can talk to a PLC directly. You don't have to have the computer involved, don't have to have software, and you don't have to get separate modules.
Okay. I've seen where they actually have the HMI or the PLC, and they have a window where they have the image, and then they have the data next to it. So, because sometimes you can tell faster based on how it looks. If you got this big, hole in the middle, you have a problem. So, but we'll talk about applications in a minute. So then we have we have this unit which I think is actually a step up from a software point of view, because the other system we'll talk about now is the TV40 that has its own dedicated computer and software. But there's a reason for that, and the pluses of that are multiple cameras.
Multiple cameras, and you can do an awful lot of analysis with that software. And I do want to point out, this is a TV36 SA, stands for standalone. There's also a GigE version, and the GigE references the GigE standard for camera output. That's the same kind of output and same kind of format that the TV46 and TV43 have. Okay. So essentially, if you had one of those cameras, you could sub this in, do the exact same thing you were doing before. The reason you might want that kind of version is that ThermoView software that we make allows you to do a lot of things that are kind of hard to do with a direct output.
Right.
You could have lots of different areas of interest. You can record these sequences so they kind of look like video, but it's much more than video. It's video with 300,000 different pixels recorded in there data-wise. Right. So if you record one of these sequences, you go back to it later, you can start to analyze. Like, I wish I had an area of interest over here to see what this was doing, or I want to compare this point with that point. You can add that stuff later if you have it recorded by the software.
Right. Because this doesn't record.
This doesn't really record. You can take screenshots. There is a possibility you can take a quick screenshot of that image and it stores on board the camera, but it's a finite number that you can really store there, and you got to get them off later.
Yeah, and most of the jobs we've seen are alarming and don't require the overhead of the more expensive camera. I mean, there've been a handful that wanted the live video, but so this is a way to get into it and decide whether there's a return on investment without deep diving.
I think if you're a design engineer trying to really analyze and optimize a process, you might want that software so that you can start going through different simulations and patterns that you see on it. If you're trying to run a process and trying to just either monitor for a hot spot or get a temperature feedback, you'd probably want the standalone version.
Okay.
We got a lot of feedback. With TV43, it was a successful product, did a great job in the field. It's still available. But we got a lot of feedback that people don't want another computer on the shop floor. I mean, the shop floor might be an aluminum rolling mill or something. It can be a very dirty place that you don't necessarily want to have another PC. It's not that convenient to do. So people wanted to implement a straight line, from the imager out to the PLC if possible.
Right. So, and if it's can get on a company network, you can look at it anywhere that you have access to that network.
Yeah.
So that makes it very...
Go into your engineering office and pull it up anytime you want.
Pull it up. Right. And then the alarming can be tied to the I/O in the camera or to your HMI PLC.
Yeah.
So that's very powerful. So from an application point of view, what are some of the applications with the imagers over the year over the years that you've run into?
Well, I went to a place just this week where we were looking at a foam product being made. So essentially, it's what's often called a web product or a web process. Means anything that kind of comes comes out in a wide strip. For them, seeing if they had differences in temperature from the left side to the right side was really important. But then you kind of pointed it out before too, is that just visually you can see if you have tears and other things. And I think a lot of times for drywall, for any laminated product, for like a lamination layer that gets put onto paper in converting processes, sometimes you get bubbles and you get a delamination, and that stuff will show up even if, often it does create a different temperature, and so you see a different temperature, but you can also see a different emissivity, which on the image shows up as a different temperature.
Right. So in that case, emissivity, the problem of emissivity becomes your friend. Like I was talking before, you look at a penny, which is the exact same temperature, and because the emissivity and the reflections are all different, you can see the penny like you were looking at.
You still see Abe Lincoln on the
there he is
on the image, even though it's all copper. It's all the same temperature.
Yeah, we were talking to somebody about printing on, and sometimes the print would get smudged, and we'd be able to test to show the smudges because the emissivity would be: are you looking at paint or are you looking at film? And they would see the difference. It would show up again, like the 4th of July.
Surprisingly, with thermal imagers, we're selling quite a few and having a lot of different applications in places where we didn't expect to, which is things like steel mills. I mean, in steel mills, we sell a lot of pyrometers. There's a lot of infrared temperature being used, but it's usually very high temperatures beyond the traditional range of a thermal imager. And a lot of times a lower emissivity, a lower wavelength is what you'd prefer for those applications. This is what we call a relatively long wavelength. It's an 8 to 14 micron wavelength. But still, in places like steel mills, you have a lot of containments for this hot molten liquid where you could have leaks. You're going to have over time that refractory will be thinning and it will start to show wear and it will start to show hot spots on the outside. And so before that becomes something extremely dangerous, you can monitor that and see it with something like a thermal imager and catch it before it's a problem.
Any other applications?
Well, you're kind of prompting me as you bring up the 30 and the 40. I want to say a little bit too about the physical nature of this design of the new product, if you don't mind. So, because I'm not sure I got to finish that. So TV40 is quite a bit bigger than this one, right? This one's about half the size, especially in terms of the front, width and height of it. But also, it's a lot more robust. And by that, I don't mean it's necessarily tougher, but I think the design, if you look at the front of a TV46, you have a piece of glass like this one, but that glass is actually a coated germanium lens. It's actually the business end of it, the real lens. And if you had anything happen to that lens, either through cleaning or through the process getting on, if you scratch that lens, it could be a significant repair. You can't field repair it. It's going back to the service center. It might be a pretty expensive change out of that lens. And this one, you just have a little protective window. It's low cost, flat protective window. The lens is inside. And so you can easily in the field change that in minutes. It doesn't cost you much of anything at all. You can have a spare on the shelf if you need to. So it's robust in that sense. And then the other thing is you have all the different lens options. So both of these cameras have a wide lens, a telephoto lens. It's basically a zoom, or else the standard lens. And on the TV40, you'd have kind of a snap-on extra accessory that you add onto the front. That gives you flexibility to change, but in most cases that makes it pretty difficult to figure out how to add an enclosure or how to put on a purge collar that you might need to keep dust off it, things like that. In this case, all those lenses, you configure them up front. They're all inside. It always looks the same. All the versions of TV40 look just like this. So the air purge collar that we make for it is relatively low cost, easy to put on here, pretty small. We have a water-cooled enclosure that can be used for this, which is actually quite small. It's about the size of the TV43 camera, naked, if you will. And all that is a lot less expensive than it was before because everything's smaller and more compact. So this is just like a easy to spec out, easy to implement, easy to mount compared to the older camera.
Okay. And you were saying you had a lot more orders from like steel mills, but the price is, unfortunately, prices have gone up in the last few years, as everything else has. So the price of that two-color sensor is
higher than it used to be.
Higher than it used to be.
Yeah, sure.
And this is really not that much more. It's a few thousand more. So 300,000 points versus one. There may be some advantages to that.
It's getting closer and closer, right? Because this price point is lower than our previous cameras.
Right.
Everything else is coming up. I mean, for not much more than a single point sensor, you can get into something like this. That's why we're trying to introduce it to as many people as we can to say, well, is this the right thing for your application? Because you can get a lot more information out of it.
So I have my story, but do you have the weirdest infrared application you've ever entailed?
Let's see. I'm not sure if I have a good one here. I have one that you and I saw that I thought was really interesting is essentially filling or squirting of liquid chocolate into enclosures that sometimes it misses. Sometimes it's just not there. Sometimes things get clogged up. It wasn't so much anyone worrying about whether that was at 40 degrees or 50 degrees. It was sometimes you just simply miss and you'll ship a bad one if you don't see it. And I love an application like that. You can implement something. You can put a number of areas of interest in there and say, look, if any of these doesn't get filled or doesn't get run, I want to know it. And it can pick it out for you just in a second.
Yeah, I think we would have seen that. We would have seen that. That, didn't turn into a sale for us, but it's very interesting application, and it probably would have shown up. You've got hot chocolate now in a cold surrounding, and it would have lit up like a Christmas tree.
Maybe someday. One other thing that's kind of interesting that I've seen is I didn't realize this, but at places where you have huge piles of storage of things like coal, wood chips, other biomass, that's actually becoming more and more common because you have whole power plants now running on biomass. Sometimes those wood chips will just sit there and chemically break down and internally heat, and they can just combust on their own. And so you have things like this, and it's now that the price point gets more and more attractive, it's realistic to say, I want to monitor this entire yard, and you're talking about acres and acres, and see if anything heats up to the point where it either has combusted or might combust. And, I want to monitor that as like a security and safety aspect.
Right, and that's true because as the price comes down, 5-10K less than its predecessor, you're talking about a lot of these places are like 10 cameras.
Yeah.
Because they're a big area, and that's significant money.
Yeah. It is possible. We do have accessories, too, that could take this where it looks left and looks right and pans around, a pan and tilt accessory, where that can be part of it as well, where you monitor a lot more area with one camera. Instead of getting 10 cameras, maybe you get 4, but you have it looking in different directions.
True. Yeah. Okay. My weirdest one was this guy was he was tasked with counting moose in Maine, and he was going to import these drones, and they were going to fly over Maine, and he was looking for a profile of a moose with an infrared image, and he wasn't able to obviously put this in an airplane, but so he brought us to this nature preserve in northern New Hampshire, and it had bears in captivity, and we sat there one night in the snow, looking at bears, footprints of bears. And the other one, I've said this on a previous podcast, he just was asphyxiated on the bear peeing and knowing what the temperature of the pee was and all that. That was the strangest, most non-manufacturing. That project never got off the ground, and I heard that he might have actually gotten in trouble for importing something that was outlawed because people use it to run drugs. But so that never came to play. But that was a bizarre one. Another one
Next
was...
time you have one of those, you got to invite me along, though. That sounds interesting.
I will do that. And but yeah, that was just again, the technology can be used creatively for anything that you're looking for a temperature of.
Yeah. We have people making sure they're cooking bacon properly. I went literally within the last month to a facility making snack chips, stuff that you've seen in the stores.
Yep.
Now I know how it's made, and they were looking for, it wasn't even in this case looking for product. You could use this to make sure that the cooking was done sufficiently. They were trying to make sure that they didn't have little crumbs that get stuck in the certain parts of the oven, just ignite when they don't want them to. Right. And they can monitor all night when nobody's there. So.
The cracker industry is huge because, the color makes a big difference, which is related to how long it was toasted or baked. Because if you got a cracker in there that's a different color than the rest, you're thinking there's something wrong with this. And so, the food industry is a big deal for temperature. We know that as a company that deals in temperature. So anything you'd like to say that's more about Fluke and about the company and infrared imagers before we close here?
Well, I think, one of the things we try to be and try to do at Fluke and Fluke Process Instruments is somebody who has lots of different solutions. So as you pointed out, we have pyrometers, but we have, compact, low-cost ones. We have high-speed ones. We have the very, top-end two-color ones. We have different solutions for both imaging. We've discussed software, no software, and then the line scanners. We have a pretty broad bag of tricks, if you will, and we try to, rather than pigeonhole anyone into one particular solution, we want to have kind of anything that you might be interested in. Okay. And so I think we whenever you have a problem that relates to this kind of stuff, we'd love to help you with it and see what we can provide.
Okay. Great. And thank you, Greg, for taking the time to come up here. We're going to send you home tonight to bring bagels back for tomorrow. But we thank you for joining us for our podcast, and we hope you join us for other ones that we have. And if there'd be contact information as part of this, please give us a call or an email if there's anything we can do for you. Thank you.
Thanks.
Thank you for getting in the loop with us. We hope this podcast was informative, and if you need any assistance on anything in the thermal process industry, please feel free to reach out to us at 800-848-NETS. That's 800-848-6387. Or visit our website at www.nets-inc.com to fill out a request for information form. If there are any topics regarding thermal processes that you would like to hear on a future podcast, please send us a comment. We hope you have an awesome day every day.